This is an example of price elasticity of demand for Math 210. So we're given a demand function, d of p equals 275 minus 2p squared. And we want to find the elasticity function, e of p. So when we're finding elasticity, we're finding what the elasticity is at a particular price, p. Let's keep reading for a second. And now it says, so first we want to just write the function. So write it with p's. And then we're going to use that elasticity of demand at a particular price, $7.61. Then at that price, we want to find, is that inelastic, elastic, or unitary? And then what would our action be if we would like to increase revenue? That's part D. So here's our form right down here for the elasticity function, E of P. So when I input price, it's equal to, the elasticity is equal to the absolute value of P, price, over Q of P, demand. So notice I can call the demand function D of P or Q of P. It really is the same thing. When we're writing the elasticity function, we're just taking price divided by quantity purchased or demand multiplied by the derivative of the demand function or Q of P. So in this case, we're calling Q of P is another way of saying D of P. They're equivalent. So we just write our form. We know that at some price P, the elasticity function E of P is equal to the absolute value of price divided by quantity or demand times the derivative of the demand function. And so in this case, like I said, because we have a D of P, we called our demand function. Let's just replace those Q of P's for clarity with D of P's. And Q prime of P would just be D prime of P. And so we're also given a particular price, $7.61. So what we're going to do is we're going to just put in $7.61 into the elasticity function. So P, or price, is $7.61. And everywhere I have a P, I'm going to put $7.61. So it would be $7.61 divided by the demand function when I input or have a price of $7.61, and the derivative of the demand function at price $7.61. So I like to write this full form first, and then I'm going to evaluate each of these pieces. So here's my demand function, D of P. I just took that from above. D of P is 275 minus 2p squared. I need to input the price I'm interested at. P is equal to $7.61, and so that gives me 159.18. So at a price of $7.61, the demand, or the quantity people want, is 159.18. All right. So I also need to take the derivative of the demand function. So if I take the derivative, I'm just going to apply the power rule. If I take the derivative of this function here, the derivative of 275 is 0. The derivative of this term over here is just negative 4p to the first. So when I input price, I'm going to get an output of a rate of change. So I just want to input that same price because that's what I'm finding the elasticity of demand. I'm going to put $7.61 in for price, and I get an output of negative 30.44 over 1. So this is saying, so this is change in demand or quantity over change in price. So for every $1 increase in price, the quantity people are demanding goes down by negative 30.44 units. Well, so now I'm just going to plug all those parts into my elasticity function. So I've got here, let me go back. I have D of $7.61 is 159.18. So I'm just going to put that in right here. D of 761 is 159. And then d prime of 761 is just here, negative 30.44. So I just plug that in and I multiply. Right? Because demand is typically the rate of change, the higher price we charge, demand decreases, is typically, under most circumstances, negative here. So we take the absolute value of this because we just want a positive number. So the elasticity of demand at a price, $7.61, is 1.455. So I'm going to come down here so that my definitions say if elasticity is less than 1, then demand is inelastic, meaning I can change price and people are still going to buy it. They're not sensitive to that price change. So people will still increase, demand is still increasing. And then when the elasticity is greater than 1, that means, which is what we have here, elasticity is greater than 1, it means that even small changes in price, people will not buy as much, or the demand will be lower. So the demand is decreasing faster than the price is increasing. So in that case, I should lower prices to increase revenue. So let's see what we have here. So the elasticity of demand at that price is just 1.455. Since elasticity of demand is greater than 1, it means that we have demand is elastic, meaning small changes in price are going to result in bigger changes in people's demand. And because of that, I want to lower price. If I lower price, demand is going to go up faster than the amount of my decrease in price. So we should lower price to increase revenue.